as Thomas mentioned, I'm going to give you a quick peek under the hood of RDS today. So this is going to show a bit the architecture implementation of that. So there might be some technical parts. I hope that's okay for everybody to know how this magic is working. Yeah, and I'm going to look at the data sets, how this data lookup works, what we did for disambiguation of data, how we prepared all those pieces of data, the data sets, and performed some additional processing, how the type mapping works, entity grouping, editorial workflows, and so on. The OpenRefine integration that is mentioned here is actually a part of tomorrow's talk. So let's get started. So the data sets that we have loaded in RDS are organized as named graphs in the RDS global database. Named graphs because they allow easy partitioning of data. We can identify each piece of data where it came from and associate some metadata with that, like a label for a data set and a logo. So this is visible later on in the pages. There's only one exception. Wikidata, which is also made accessible via RDS, is a huge dynamic database, and replicating that is a lot of effort. And so we are just federating to Wikidata. But still, you can find data in RDS from Wikidata as well. And this is also interconnected with the other data sets, as we will see in a bit. So what we have available in RDS at this point in time, this is not a complete list, this will grow over time. So there's the Getty, AAT, and ULAN data sets. From GND, there's cryptographic data and entity facts, we have geonames, and as I said, big data. The plan is to integrate further data sets like VF and others over time. And this will be made available transparently and can be used for linking as well. And of course, if any of you would contribute your own data to that, this will also be made available to people. We'll see about this also a bit later. So one of the key features is finding entities, finding things like places, events, people, build works, and so on and whatnot. So Thomas had a quick overview of what you can search for, what out of those 7 main data types presented by RDS. And for that lookup to work, we need a good lookup mechanism. So if you're searching for a search term, like a name, for example, name of a person, Leonardo da Vinci or somebody, there's a lot going on under the hood. We are using a newly created architecture or abstraction, search abstraction that was built into the platform for this. And this allows searching for various ways. And the idea is to also abstract the search from the database-specific native search, using database native search where possible. So there is fast indexing applied and used where possible, but also allowing more creative uses, like we will see later when we do, for example, federation or combination of these lookup building blocks. So that means we have a couple of database-specific implementations, like a place graph, database-specific search implementation, or some fallback for just plain regular expression lookup in the database, but also the means to do remote lookup. So when we span, when we bridge from one service to another one, like for example, Florian mentioned yesterday already, you can spin up your own RDS local system that would talk to the mothership, to RDS global, and this applies the remote lookup in that case. But also there's a federated lookup, so you can also combine lookup pieces. So these are building blocks that we employ in both RDS local, RDS global. I will show a big version of that picture in a bit. I will just explain this a bit. So in RDS global, this is the system that is being hosted by SARI. We have the local database with the data sets like GND, like AAT, like ULAN and whatnot. And also we are federating to Wikidata. When you're searching for anything in there, this is applying the remote lookup to look at Wikidata, but there's also the place graph local search. This is being federated. So basically we're just combining the results from all of those data sources, meaning you get one big result list, which has all those data sources covered. We're doing a bit of additional aggregation to, we'll get to that a bit later on. This serves to cross-link, cross-reference entities. So for example, if you have a Leonardo da Vinci in AAT and also in Wikidata, you would want to be presented this as a single result, not just disparate separate results. And then this is also being made available via an endpoint, a REST endpoint. So this can be consumed by other systems. This could be just any external system like OpenRefine or other systems. Florian mentioned the TEI editor yesterday, also as another option. But also, if you're running your own RDS local system. So any organization could just spin up their own system, which is more or less a copy or a variant of that RDS global system, just that this would not typically host the big data set. So you can start out with an empty database and just use this as your own search front end, which talks via this remote lookup to the RDS global system. Or if you are interested in authoring your own data in that system, you can also combine the search into your own database. And again, this is being federated, so you have a single search interface and you will find anything both from your local data sets and as well the public data sets hosted by RDS. So one important part of that also is disambiguation. So say we are searching, like in this example for Michelangelo Buonarroti, how do you know that you found the right one? So this is both because you have the same person or the same entity you're searching for in multiple data sets, as well as maybe different entities of the same name. So being able to distinguish between those is very important. What we're doing here is we're showing the description for that entity. So for example, here this first entry, you see this has a description, which in this case is in German. This is because it's from GND, the German National Library there. So they have German labels in that case. And as Thomas mentioned, of course, having multilingual access benefits here. Just in this case, the data doesn't have that, the data set. But in this case, at least it helps to distinguish between Michelangelo Buonarroti, the person you would typically likely want. That's also why it's ranked first, because this is the main well-known person. But there's also his nephew, which has the same name. So having a description really helps in that case. So the description might come from your dataset as a ready-to-use attribute or property that is contained as part of the dataset, but sometimes there's no ready-made description. So we'll have to create one. And for that, we built a description service, which allows basically to create a one-line summary of an entity. That's very important. And typically what you want is, for a person, you want to represent this person in a different way than, for example, a place. For a person, you might want to show the occupation or affiliation or the lifespan. And for a place, you would rather want to show some geographic references, like for a city, it's contained in some country or some region or whatnot. So you have different properties and you want to describe that. And for this, we built a mechanism where you could, based on some model annotations. So in this case, we see this is for something of class GND person. So a person as described in the GND dataset. And here we are describing a couple of properties that are contained in GND, and we are mapping this to, let's say, logical names in this case. And these logical names are then used in a type-specific template that is being rendered as description. This looks a bit technical, but what this does basically is say, for a person, we want to render the occupation, some biographic value, whatever that is. This is being mapped here or not. For GND would show something that is contained in the dataset. Maybe some place relation, like where the person originated from, was born or was living, main part. If there's a defined the birth date, we would show that. If that person already died, then we also show the death date in this case, just so we get basically the information about a person, affiliation, occupation, lifespan in this case. For a place, as I said, you might choose different fields. And this is quite flexible, as it allows us to describe different types of entities and also different representations of those. Different representations is also an important part. We're getting to this in a bit, because here you see this is describing a person as a model in the GND dataset. But as you might be aware of, different datasets model their entities, their people, events, places, built works, piece of art in different ways. So they're using different properties to describe those. And in RDF, this means you would typically have different predicates and classes to describe those objects. So just to show, for example, a person has different representations in different data sets. This just shows that, for example, there's a Wikidata person here, this one person concept that might be from GND, and this is yet another person, maybe from ULAN or so. So in all those data sets, we have already different representations of, for example, type person. And we are mapping all of those to some RDS specific construct. So that means when you're searching for something, you just say, I'm searching for person, RDS person, so to say, and this is being mapped under the hood to the individual respective types in RDS. And we apply some type translation there. Yeah. Here you'll see, here's another entity type E21 person. This is from Cydoc CRM. The idea is there that this ontology is used, this type schema is used for describing a person when you create your own records using RDS local system. So in the predefined, ready to ship RDS local instance that is. So if you're using this as it comes out of the box, if you create your own data, and if you contribute this to RDS, this would be modeled using Cydoc CRM. And there we have another person type, which uses the Cydoc CRM ontology. So besides type mapping, we also apply grouping. So Florian was this showing yesterday a bit. So for example, here in this case, searching for Leonora Carrington returns results in 3 data sets. So 3 individual ones. You see this is from Wikidata, this is from ULAN, and another one from GMD. And what we ideally want, we are searching independently in all those data sets. We get all of those entries independently. But what we want is to group together the same entity. You see here, there is only 1 result for each of those, but here we have 3, and this is the expanded result. So typically you would just see that upper part here, and this gives some hints that this person is contained in 3 data sets. And if you, for example, want to reuse the identifier, the IRI of the data sets, you can either choose the one from the preferred one. In this case, it's ULAN, or you could choose the one of the others that you really want to use for your own reference or linking in this case. So how does it work? The data sets are interconnected. So Florian was showing this picture yesterday quickly. I just copied his slide. Thanks, Florian. And this shows that the data sets have some links to between them. And actually, the biggest hub for this piece of information is Wikidata, because Wikidata has all those identifiers to other data sets. It's not just Wikidata, there are also some links between other data sets, but this is a good integration hub. We just need to apply some additional processing in this case, because these identifiers are just, in most cases, the numeric or a literal identifier. So in order to use that for linked data, to turn that into RDF IRIs, we need to process this a bit to put that in the right namespace and everything. But basically, those links are there. We extract them and materialize them into the database. So when searching for something, like in this example again, we find one hit, and we can also link automatically to other hits which describe the same person based on those links. And just returning those references, this is the technical part behind the scenes, but also this visualization takes care of grouping this correctly and showing this in one go. This is a summary of that again. And the links, by the way, that I have included in those slides, if you're watching them later on or for recapitulation, point to the RDS GitHub repository where all of this is implemented. So you have some pointers on how this is done and where to find this information if you want to look at this in more detail. So let's go to data authoring. Data authoring in this case is for people to use RDS local system to save their own research data, as Thomas was mentioning in his example, describing earlier projects, where you would, for example, create records for a person's event, places, build works, and so on. We have predefined a couple of forms for this. So this is all a form-based interface that is easily defined and can be also extended. We're getting to this in a later session. And you can create your own local records, and those local records then can later on, sorry, before I get to the publishing, those local records follow the SARI reference data model. So there's a documentation link also there. This is all described in details, the fields that are available there, what they would see. Of course, this is currently what SARI defines, but this can be changed, extended to whatever your personal needs are or your research group's needs are based on field definitions, which describes all those form fields, and what the meaning is, what data types there are, what they link to, if they are not just literal values, but also linked to other entities, like a person would link to father, to mother, for example, to children, to other related entities, and so on. Yeah, so authoring in this case also may include editorial workflow. Editorial workflow in this case means, let's say your group of researchers, everybody just looks at your subject of research. Maybe you're looking at some book or so, and you're creating records describing entities, persons, event, place in this book. And before publishing those, somebody might want to do some approval or editorial workflow, for example, to make sure that everything is in good quality, that there are no typos in names and everything is in order. So we implemented some editorial process where some reviewer may say, okay, this is accepted or rejected, so maybe it has to be reviewed again and improved. And then at some point, one reaches approval of records, and this piece of data, once it is approved, can then be pushed or published to RDS Global. This is of course optional, right? So there's no need to publish, but SARI is welcoming additions to their data sets. And this also means that all the data sets that are published are made available to other people as well. And one of the important points here is, if I go back 2 steps. So for example, when creating records, this might be your own personal view on some entity like a person. Let's say you have some new insights on Michelangelo Buonarroti and want to take note of that. But ideally, even though you're creating your own data, you would want to link to existing Michelangelo entity from one of those reference data sets. That's why when creating such a person record, you would first be asked, hey, does this relate to any existing person? So before creating new entities, which are kind of standalone or not linked anywhere, we would rather try to find the corresponding existing record and link to that. So in the end, this becomes a big mesh of linked data and can be properly related to existing data where relevant and possible. So this data can be published to RDS, and basically each organization participating in this publication process gets its own name graph, basically a data set on RDS. So you can publish to that own name graph and only modify that, of course. So all the public reference data sets are protected, and all the other organizations' data sets are protected accordingly. So you can modify and publish your own data sets. And publishing, once you have entered some configuration information, which Florian might show later on, you can just press the push records button, and then this is being published to RDS Global, and that will also be found when searching for those on RDS Global. But so, for example, for reuse by other entities, by other researchers and organizations. So again, I stole those slides from Florian. This is just a get good process. So you can either just push from your RDS local to RDS Global, but in the end, this might lead to a hub and spoke architecture if you want, or basically RDS Global being the central place to accumulate data sets over time, building its own linked open data cloud, hosting a lot of data sets which are crowdsourced by a lot of participating organizations. So what did we have to do to make that happen behind the scenes? It's just a summary for interested people who are also working with data sets and doing data mangling and loading and whatnot. It's a very quick summary. As I mentioned, we are hosting, for example, AAT, ULAN, GND datasets. We have a couple of scripts that download those datasets. This might take a while sometimes, or require retries or downloading portions, because these are huge datasets, and then they are uploaded to our internal database. We are also extracting those links between the datasets that I mentioned before in an automated way. We are pre-processing this, like for example, the links in Wikidata, which are just literal identifiers to put them in the right namespace. So we have proper RDF IRIs and creating those, and those are materialized also in the database. This materialization of links greatly speeds up also the references or dereferencing those links. So they would not be searched on the fly, but rather be prepared and materialized in the database already. As most of those data sets are rather static, this is the best option in the sense of performance and being up to date also. So for example, if there are new additions or new dumps available from any of those data sets, these steps can simply be redone, and let's say in an overnight update or refresh cycle, and everything is up to date again. So this goes for the main hosted reference data sets. Of course, all those individual data sets that are contributed to RDS, they are just always being up to date, put up to date from the respective creators of the data. So for example, if any research organization, some university research institution contributes data to RDS, you can just push that and keep it up to date that way, and also re-update this again by contributing more data.